If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see an example on sinusoidal steady state analysis, nodal analysis. Question: calculate the voltage at nodes 1 and 2 in the circuit of figure using nodal analysis. So here for this circuit, we have to find the value of this node voltage and this node voltage. So first of all, we will copy this circuit from here. Now let's see the solution. So here we can see it is a node. So let's say this is node number 1 with voltage V1. Now next, here also this is a node. Let's say this is node 2 with voltage V2. Now let's say this is a reference node or ground node. Let's assume this as current I1, this as current I2, this as current I3, and this as current I4, and this current as current I5. This is current I5. Now let's apply KCL at node V1. So apply KCL at node V1. Now according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now at this node, the entering current is, there is no entering current at this node, all the currents are leaving. So here we can write 0 is equal to, now leaving currents are I1, I2 and I5. I1 plus I2 plus I5. Now let's write I1, I2 and I5 in voltage form. So I1 is equal to V1 minus 0 divided by minus J2. V1 minus 0 divided by minus J2, then plus, now this I2 is V1 minus 0 divided by 10. V1 minus 0 divided by 10, then plus I5. So this I5 is V1 minus V2 divided by J4. V1 minus V2 divided by J4. Now it is equal to 0. Now let's simplify it. So here we can take this V1 common. So V1 in bracket 1 upon minus J2 plus 1 upon 10, then plus 1 upon J4, then plus V2 in bracket minus 1 upon J4 is equal to 0. So V1 in bracket, let's simplify this, 1 upon minus J into 2 plus 1 upon 10 plus 1 upon J into 4. So it is 0.1 plus 0.25 J. 0.1 plus 0.25 J plus V2 in bracket minus 1 upon J into 4. So it is 0.25 J is equal to 0. Let's consider this as equation number 1. Now next we will apply Here at this node also we can see that this 20 at an angle 30 degree ampere is the leaving current. So we forget to add this current. So here we have to add plus 20 at an angle 30 degree. So here also it will be 20 at an angle 30 degree. So plus 20 at an angle 30 degree is equal to 0. Then we can convert this polar form to rectangular form, 20 at an angle 30 degree. So it is 17.32. So on right side it will be minus 17.32, then minus 10J. Here also it will be this value. Now consider this as equation number 1. The other things are correct. Just we have forgotten the 20 at an angle 30 degree ampere. Now next apply KCL at node V2. Again, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now at node 2, here we can see entering current at this node is 20 at an angle 30 degree. 20 at an angle 30 degree, then plus this I5 is also entering. So I5 then is equal to, now leaving currents are I3 and I4. So I3 plus I4, 20 at an angle 30 degree plus, now this I5 is V1 minus V2 divided by J4. V1 minus V2 divided by J4 is equal to I3. Now I3 is V2 minus 0 divided by J2. V2 divided by J2, then plus I4. So this I4 is V2 minus 0 divided by minus J5 divided by minus J5. So now let's simplify this. So V1 divided by J4 minus V2 divided by J4. This term, we have taken this term first. Then we can take this on left side. So minus V2 divided by J2, then minus V2 divided by minus J5 is equal to, we can take this on right side, but before that we have to convert this 20 at an angle 30 degree into rectangular form. So 20 at an angle 30 degree in rectangular form, it will be 17.32. So on right side it will be minus 17.32, minus 17.32, then minus 10J. Now let's simplify this. So V1 in bracket 1 upon J4, 1 upon J into 4. So it is equal to minus 0.25, minus 0.25 J, then plus V2 in bracket. Now let's simplify this. So here it will be minus 1 upon J4, minus 1 upon J into 4, then minus 1 upon J2, then minus 1 upon minus J into 5, minus 1 upon minus J into 5, so it is equal to 0.55 J. (0.55 J) is equal to minus 17.32 minus 10 J. Now let's say this is equation number 2. Now we got two equation 1 and equation 2. Now we can either solve it by matrix method, or we can solve this by finding the value of V1 first and then substituting the value of V1 here. So let's solve this by using matrix method. Solving equation 1 and 2. Let's put this in matrix form. So from equation number 1, first we have to take this V1 term, then from equation number 2, this V1 term, then next from equation number 1 again, let's take this term, then from equation 2, let's take this term, then next we have to find the two unknowns, which are V1 and V2. So here it will be V1 and V2 is equal to, now is equal to terms are from equation 1, it is this value, and from equation 2 again it is the same value. So let's find the value of delta. Delta is equal to, we have to take the determinant of this. So determinant of this will be, let's solve this into this. This term multiplied with 0.55 J, 0.55 J, then minus this minus 0.25 J multiplied with 0.25 J. Let's solve this in calculator. 0.1 plus 0.25 into J. (0.55 into J), then minus 0.25 into J multiplied with 0.25 into J. So it is equal to this value, minus 0.2 plus 0.055 J. So this is the answer for delta. Then next we have to find the value of delta 1. So for finding delta 1, again we have to take the determinant of this matrix, but here this time we have to replace its first column by this value. So let's take it from here. Now this into this term into this 0.55j, then minus this into this. This term into 0.25j. So again let's solve this. Minus 17.32 minus 10 into j multiplied with 0.55 into j minus 17.32 minus 10 into j, then multiplied with 0.25 into j. So it is equal to 3 minus 5.196 j. So this is the answer for delta 1. Then next we have to find the value of delta 2. So for finding delta 2, again we have to take this determinant, but this time we have to replace its second column. We have to replace this second column by this value. So this into this term multiplied with this term, then minus this term minus 0.25 minus 0.25j multiplied with this term. So it is equal to, let's solve this in calculator, 0.1 plus 0.25 into j multiplied with minus 17.32 minus 10 into j, then minus 0.25 into j multiplied with minus 17.32 minus 10 into j. So it is equal to 3.26 minus 9.66 j. So this is the answer for delta 2. Now we got delta 1 and delta 2. So we can find the value of V1 and V2. So V1 is equal to delta 1 divided by delta. The value of delta 1 is, this is the value of delta 1, divided by the value of delta is, this is the value of delta. Now it is equal to 3 minus 5.196 into j divided by minus 0.2 plus 0.055 into j. It is equal to this much. in rectangular form. In polar form, this will be shift to 3. So it is 28.92 at an angle 135.37 degree volt. So this is the answer for V1. V1 is equal to this value, this much value. Now next we have to find the value of V2. So V2 is equal to delta 2 divided by delta. Now the value of delta 2 is, this is the value of delta 2, and the value of delta is divided by the value of delta is, this is the value of delta. So V2 is equal to, let's solve this, 3.26 minus 9.66 into J divided by minus 0.2 plus 0.055 into J. Now it is equal to this much shift to 3. So it is 49.15 at an angle 124.02 degree volt. So this is the answer for V2. In this problem, what we have to find? We have to find the value of, calculate the voltage at nodes 1 and 2. So here we have to find this node voltage and this node voltage by using nodal analysis. So here, this is how we can find the value of node voltage V1 and V2 by using nodal analysis. Don't forget to check out the other videos on this channel, and thanks for watching.